let's do these practice problems that you were to do over the weekend. Let's go to work. We are graphing quadratics in intercept form. It's called intercept form, also known as factored form. As a quick refresher, that is y equals a times x minus p times x minus q, where p and q are your x-intercepts or your zeros or your solutions. Notice the negative sign. Remember, we say, hey, that means opposite, right? So it's going to be opposite of -6, which is 6. And it's going to be opposite of -4, which is 4. So my two intercepts are 4 and 6. Once I have my two intercepts, I got to find the spot between them. This one's pretty easy because they're 2 apart. So my axis of symmetry is at 5. X equals 5. So now I take that 5 and I plug it into the equation. F of 5 would be 5 minus 6 times 5 minus 4. 5 minus 6 is a -1. 5 minus 4 is a 1. -1 times 1 is a -1. So my vertex now is 5, -1. 5, -1. There is my parabola. That's more than enough. Just to double check, my A value is 1, A. So I went up 1, over 1, up 1, over 1. That gave me those same 2 points. So there's something to check yourself on. We were doing the problems on the left-hand side, the left-hand column. Okay. This one we talked about just a little bit in class, and I said, hey, we could think of this 2 ways. You could either think of it in vertex form, y equals a times x minus h quantity squared plus k. And you could say this basically means, plus 0 there, right? So my vertex would be 3, 0. That's one way to think of it. Or we could think of it as, hey, this is the same thing as y equals x minus 3 times x minus 3, if you're thinking about it in vertex form. So this would have what intercepts? 3 and 3. Well, let me plot 3 and 3. Hold on. Can I call you right back in about 2 minutes? Yeah, go ahead. Yeah, it doesn't matter. Yeah, what's up? Oh, it's nice to have a home game, but it doesn't matter. We'll play anybody. Yeah. All right. Yep. Bye. All right. Sorry about that. A little enjoyment for you. A little entertainment there. Okay. So anyhow, notice when you have the same one, well, I can't plot it 2 different times. I mean, I can, but you can't really see the difference. So anytime that we have this, that, we're only going to have 1 point on the x-axis. That's kind of cool. Well, what happens then? Well, now we use our a value, which is 1, to go up 1, over 1, up 1, over 1, to get our other 2 points. This is a special one. This is a perfect square trinomial. It is something that you're going to become familiar with. So that one may have given you a little bit of trouble, but now we see what's going on. Let's go to the second page, and I'm going to work kind of fast here because we've already talked about the ins and outs. I can see my intercepts are going to be 5 and 1. So I plot those 2 points, 1 and 5. The middle between that goes 1, 2, 3, 4. So they're 4 units away from each other. So in the middle, right there, middle. You know what? Let's go to red. It's kind of hard to see that blue there. 1 and 5. Okay. So right in the middle then is x equals 3. Plug it in. F of 3 equals 3 minus 5 times 3 minus 1, which is -2 times 2. And negative 2 times 2 is a negative 4. So my vertex then is 3, negative 4. 3, negative 4. Do I really need any other points? No. But I could use my A and go up 1, over 1, up 1, over 1. And then I got more points. The more points, the better. I don't have to have more because I know we're dealing with parabola and all that good stuff. But there you go. Next problem. My intercepts are negative 2 and positive 4. Negative 2, positive 4. The middle of that's going to be 1, 2, 3, 4, 5, 6. So 1, 2, 3. It's going to be at 1. So I'm going to put that in the middle here, 1. So I need to find f of 1. So I got 1 plus 2 times 1 minus 4. 1 plus 2 is 3. 1 minus 4 is a negative 3. 3 times a negative 3 is a negative 9. So plot that point, negative 9. There it is. Do I need any more points? No, not really. But let's write down what I have so far. I already know that I have 4, 0. And I've got negative 2, 0. I'm going to use my A value again to go up 1, over 1. There's another point. Up 1, over 1. There's another point. So that's 0, negative 8, and 2, negative 8. If we wanted to also fill in the chart there, we can do that in that fashion. There is my beautiful parabola. Number 5, 2. So I got negative 2 and negative 8. Sorry. Remember, we're using the opposite of what we see there in intercept form. It's the opposite. So negative 2 and negative 8. Those are 1, 2, 3, 4, 5, 6 units away. So 1, 2, 3 is half of 6. 3 away would be at negative 5. So x equals negative 5. That is the value I got to find. I got to find f of negative 5. So I can find the other half of my vertex. Right now, I know my vertex is negative 5 something. How do I find that something? Glade. Plug it in, plug it in. So negative 5 plus 2 and negative 5 plus 8. Well, negative 5 plus 2 is a negative 3. And negative 5 plus 8 is a positive 3. Negative 3 times a positive 3 is a negative 9. So my y value of my vertex is negative 9. Let's plot that. Now I also, again, just filling in this chart to be thorough, I already have negative 8, 0. I already have negative 2, 0. I'm going to use my A value again. I'm going to go up 1, over 1, up 1, over 1. And if I had plugged in negative 4 and I had plugged in negative 6, I would have got out negative 8. Or negative 8. So there is my parabola. Cool. Well, we're having fun now. Let's go to this last page. This last page is given to us a little bit different. Okay. Let's look at it like this. This tells me my zeros or my x-intercepts. My zeros are 3 and 9. That's what it says right there. Your zeros or your x-intercepts or your solutions are 3 and 9. So every time I found those two intercepts, I find the middle. What's exactly in between? 1, 2, 3, 4, 5, 6. So half of 6 is 3. So 1, 2, 3. So my axis of symmetry is going to go through 6 here. So my vertex is going to be somewhere on that line, okay, at x equals 6. But I also know that I have a max. If I have a maximum, that tells me, hey, this parabola must go like that in order to have a maximum, right? And that maximum, the maximum value is always the y value. See that y? So the y value, the maximum value must be here at y equals 4. That means the vertex is right there. That's all I need. Boom. There's my parabola. Cool. Wasn't nearly as hard as it looked, was it? So looking at number 23, I have x-intercepts or zeros at negative 2 and 2. So immediately in the middle between those is the y-axis. It has a minimum of negative 8, which would be, minimum would mean that it's going to open upward, right? And that would be way down here, negative 8. And there is my parabola. That's even easier than the others, isn't it? So here I got a 0 at -5 and a -1. 1, 2, 3, 4. So right in the middle would be -3. And -3 has a max. Max tells me it's going to open like that, and it has a maximum at 4. Boom. There is my parabola. All right. Hope that helps. And I am sure you're going to be doing the remaining problems. Hey, have a great day.